Ambient Invisible Intelligence. Introduction. In a future where technology seamlessly integrates into our lives, Ambient Invisible Intelligence promises to revolutionize how we interact with the world. Imagine a world where AI anticipates your needs and acts without being seen. Join us as we explore the cutting-edge field of Ambient Invisible Intelligence and discover the potential it holds for the future. Stay tuned at Tech Revolution. Understanding Ambient Intelligence. What is Ambient Intelligence? Ambient Intelligence, AMI, refers to digital environments that are sensitive, adaptive, and responsive to the presence and activities of individuals. These environments utilize AI and IoT Internet of Things to create seamless, intelligent interactions without the need for direct user input. Ambient intelligence aims to enhance the quality of life by making technology virtually invisible while providing valuable services. Key characteristics and principles: context awareness, understanding and responding to the context in which an individual is operating. Personalization, adapting to the preferences and needs of each user. Anticipation, predicting user needs and proactively providing assistance. Adaptivity, continuously learning and evolving based on user interactions. Differences from traditional AI systems. While traditional AI systems often require direct user interaction, ambient intelligence works quietly in the background, integrating seamlessly into daily life. It focuses on creating a natural and intuitive interaction with technology, making it almost invisible to the user. Historical context and development. The concept of ambient intelligence has been around since the late 20th century, evolving with advancements in AI, IoT, and sensor technology. Today, it represents the convergence of these technologies to create intelligent environments that improve the human experience. The role of sensors and IoT in ambient intelligence. Importance of sensors and IoT devices. Sensors and IoT devices are the backbone of ambient intelligence, collecting and transmitting data about the environment and user activities. These devices enable ambient systems to understand and respond to the context in which they operate. How sensors collect and process data. Sensors gather data such as temperature, light levels, motion, and sound, which is then transmitted to a central system for processing. Advanced algorithms analyze this data in real time to make informed decisions and trigger appropriate actions. Integration of IoT devices into ambient intelligence systems. IoT devices, such as smart thermostats, lights, and appliances, are integrated into ambient intelligence systems to create a connected environment. These devices work together, communicating through a network to provide a seamless experience. Examples of sensor and IoT applications in ambient intelligence: smart homes, automated lighting, heating, and security systems that adapt to user preferences and behaviors. Healthcare, wearable devices that monitor vital signs and send alerts to caregivers. Urban environments, smart traffic lights and public transportation systems that optimize traffic flow and reduce congestion. Retail, personalized shopping experiences through smart shelves and digital signage. AI algorithms and machine learning in ambient intelligence. The role of AI algorithms in processing data. AI algorithms are essential for processing the vast amounts of data collected by sensors and IoT devices. These algorithms analyze patterns, detect anomalies, and make decisions based on real-time data, enabling ambient systems to respond intelligently to user needs. Machine learning techniques used in ambient intelligence. Machine learning techniques, such as supervised learning, unsupervised learning, and reinforcement learning, are used to train ambient systems. These techniques enable the systems to learn from past interactions and improve their performance over time. Importance of real-time data analysis and decision-making. Real-time data analysis and decision-making are critical for the effectiveness of ambient intelligence systems. By processing data instantaneously, these systems can provide timely and relevant responses, enhancing the user experience. Case studies of AI algorithms and ambient intelligence applications. Smart home assistants. AI-powered voice assistants that control home devices and provide personalized recommendations. Healthcare monitoring systems. AI algorithms that analyze patient data and predict potential health issues. Urban planning. AI models that optimize city infrastructure based on real-time data from sensors and IoT devices. Real-world applications of ambient invisible intelligence. Smart homes, enhancing comfort and efficiency. Ambient intelligence transforms smart homes into responsive environments that anticipate and adapt to user needs. Examples include automated lighting and heating systems, voice-activated assistants, and security systems that learn from user behavior. Healthcare. Improving patient outcomes and monitoring in healthcare. Ambient intelligence enables continuous monitoring of patients through wearable devices and smart sensors. These systems can detect health anomalies, provide reminders for medication, and send alerts to caregivers, improving patient outcomes. Urban environments. Optimizing city infrastructure and services. Ambient intelligence plays a significant role in smart cities, optimizing infrastructure and services for residents. Examples include smart traffic management systems, energy-efficient buildings, and responsive public transportation networks. Workplaces. Increasing productivity and employee well-being in workplaces. Ambient intelligence enhances productivity and well-being by creating adaptive environments. Smart lighting and climate control systems, personalized workspaces, and real-time collaboration tools are just a few examples of how ambient intelligence benefits employees. Retail and commerce. Personalizing customer experiences. Ambient intelligence revolutionizes retail and commerce by providing personalized shopping experiences. Smart shelves, digital signage, and AI-powered recommendations create a tailored shopping experience, enhancing customer satisfaction and loyalty. Ethical and privacy considerations. Balancing convenience with privacy. While ambient intelligence offers numerous benefits, it also raises privacy concerns. It is essential to balance the convenience provided by these systems with the need to protect user privacy and data security. Ethical implications of ambient intelligence. The ethical implications of ambient intelligence include the potential for surveillance, data misuse, and bias in AI algorithms. Ensuring that these systems are designed and implemented ethically is crucial for maintaining public trust. Addressing concerns about data security and surveillance concerns must be addressed to protect users from potential misuse of their data. Implementing robust security measures and transparent data policies can help mitigate these risks. Strategies for ensuring ethical use of ambient intelligence systems. Transparency. Clearly communicating how data is collected, used, and stored. Consent. Obtaining informed consent from users before collecting and using their data. Accountability. Holding organizations accountable for the ethical use of ambient intelligence systems. Bias mitigation. Implementing measures to detect and mitigate biases in AI algorithms. Challenges and limitations. Technical challenges in developing ambient intelligence systems. Developing ambient intelligence systems involves several technical challenges, including ensuring reliability, scalability, and real-time performance. Addressing these challenges is crucial for creating effective ambient environments. Integration and interoperability issues, ensuring that different EOT devices and sensors can communicate and work together seamlessly, is a significant challenge. Standards and protocols for interoperability are essential for the success of ambient intelligence systems. Ensuring scalability and reliability, ambient intelligence systems must be scalable and reliable to handle increasing amounts of data and users. Ensuring that these systems can maintain performance and reliability as they scale is a key challenge. Overcoming user acceptance and trust barriers. User acceptance and trust are critical for the success of ambient intelligence systems. Addressing privacy concerns, ensuring transparency, and demonstrating the benefits of these systems can help build trust and encourage adoption. Future trends and innovations. Emerging trends in ambient intelligence. Emerging trends in ambient intelligence include the integration of AI with edge computing, advancements in sensor technology, and the development of more sophisticated machine learning algorithms. These trends will drive the evolution of ambient intelligence and expand its applications. Predictions for the next decade. In the next decade, ambient intelligence will become more widespread and sophisticated. Predictions include the proliferation of smart environments, the development of more advanced AI algorithms, and the integration of ambient intelligence into various industries, from healthcare and education, entertainment, and transportation. Conclusion. In conclusion, ambient invisible intelligence represents a significant advancement in how we interact with technology. By seamlessly integrating AI and EOT into our daily lives, ambient intelligence enhances convenience, efficiency, and well-being. However, it is essential to address ethical and privacy concerns to ensure the responsible use of these systems. Stay informed and engaged with Tech Revolution as we continue to explore the frontiers of technology.